So I want to give an example now of counting objects recursively, which will also be a nice tie-in with the domino stuff we did last time. So question, how many ways can we tile a chessboard with dominoes? Or let me say, so it's not going to be a chessboard. It's not going to be 8 by 8, but it's going to be 2 by n. So let me write this down. How many ways to tile a 2 by n checkerboard with dominoes? So for example, if we just do a quick, so it's 2, and let's say it's a 2 by 3, then we could tile it like this. That's 1. Or we could tile it like this. That's 2. Or we could tile it like this. That's 3. And I think that's all the ways. So 3 ways. Let me write them graphically as like boop, 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 and boop, boop, boop. I hope these are sufficiently clear cartoons. But if you've seen me draw them, then I hope you'll understand. So how can we count the number of ways to do this in general? In order to do it for arbitrary n, we do not want to do it the way I just did it, right? That's going to take a long time and be very unpleasant. So here is a recursive way of doing it. So we will count recursively. Recursively. So n equals 1. Our checkerboard looks like this. And we can tile it in exactly one way, like that. So one way. For n equals 2, our checkerboard looks like this. And there are 2 ways. Like this, or like this. 2 ways. And now, we can perform the following trick. For n greater than 2, we can consider the following 2 options. So I'm going to draw it open-ended like this. Or let me draw it like this. So one option for what we do, right, let's step back for a second. We're going to look at what we're doing at the very left end. And there's 2 options for what we do there. Either we put 1 domino vertically, or we put 2 dominoes horizontally. And let's consider what happens in each of these cases. So these are the only 2 ways that you can fill up these 2 squares, right? And in each case, so on this side, what we're left with is a 2 by n minus 1 board. So the number of ways to complete this tiling are the number of ways to tile a 2 by n minus 1 checkerboard. And likewise on this side, we've taken up the first two squares. So there are 2 by n minus 2 squares left. So the number of ways to complete this tiling is the number of ways to tile a 2 by n minus 2 checkerboard. And we conclude from this, so number of 2 by n tilings is equal to the number of 2 by n minus 1 tilings plus the number of 2 by n minus 2 tilings. And if we write an equals number of 2 by n tilings, we get this recurrence that an equals an minus 1 plus an minus 2. And at this point, hopefully, this will look familiar. These are the Fibonacci numbers. Or to be precise, the recurrence alone does not tell us that it's the Fibonacci numbers, but we need to have the same initial conditions as well. So in fact, we have, as we saw, a1 equals 1 and a2 equals 2. And this is the, I believe, second and third Fibonacci numbers. So to be precise, a sub n is f sub n plus 1. So we can count the number of tilings of these checkerboards in a recursive way. And the number of tilings turns out to be a very familiar recursive sequence, namely the Fibonacci numbers.